Multi-protocol label switching frame mode configuration. Well, what we've been talking about up till now in some of the previous videos with MPLS concepts have really been based around MPLS frame mode technology, which means that you're just modifying frames, squeezing in labels, and allowing them to go much faster than they could typically if they were using just a normal routing process. So the frame mode configuration of MPLS is so simple. I almost don't even want to hit the objectives because I'll probably give away everything that you have to do. What you see right there in that list is a step-by-step of turning on MPLS frame mode. By the time we're done with this video, you'll know every piece of it. All right, let's jump right into configuring frame mode MPLS. This is the story. We've got two routers, Redwood and Pine, that are directly connected, actually over an Ethernet segment. It's just a straight crossover cable. It's going to be a very small topology because you'll find out that enabling MPLS is a piece of cake. You just turn it on and let LDP do the rest and populate that label database. I just want to get you familiar with what the diagram looks like. Now let's get familiar with some of the IP addressing. I'm sitting on Redwood right now. I'll just do a quick show IP interface brief. I have Ethernet 0, which is 192.168.1.2. Oops. I'll do a show CDP neighbor detail. And you'll see that we have the Pine router remotely, 192.168.1.1. Now I've also configured a few loopback interfaces on this router because between these two routers, I have enabled EIGRP. You can see Autonomous System 50. They're routing for the proper networks, 10 and 192.168.1. I also have enabled Pine on the other side for the same thing. So let's hop on over to Pine. 192.168.1.1. I got in and logged in. By the way, if you're ever curious, how on earth did you just telnet straight there without a password? Just go underneath your VTY ports and type in no login. Obviously a lab environment thing. So I've telnetted straight over to Pine, got into privilege mode, and I'll do a show IP route. And we are receiving the loopback interfaces via EIGRP. So I just want to make sure I lay that foundation that MPLS needs a routing protocol. It's not just going to magically take care of your whole network. I'm running EIGRP here. You could be running RIP, you could be running BGP. Whatever it's going to be, you have to have a populated routing table. Because remember the steps of MPLS we talked about in the concepts video about MPLS is it's going to go through and give each route its own label, its own little tag, so that it can quickly refer to it at layer 2, but it is not responsible for getting the routes there. That's your job, either statically or dynamically. Now, the first thing that we have to make sure is enabled on Cisco routers before MPLS will function is Ceph. By default, in very new routers, and just about every series, Ceph is enabled by turned on. So you don't have to worry about doing this on brand new routers with brand new iOS versions. But sometimes it's just a good practice to go into global config mode and type in ipceph. I'll hop over to Redwood as well, global config, and type in ipceph. Now do know that on a production router, if there are a lot of routes in your routing table, and I'm not talking hundreds or even thousands, I'm talking tens of thousands of routes in your routing table, that's where this command may become dangerous and maybe one of those commands that can lock your router because it does move everything in the routing table over to a separate routing table. We talked about it earlier as well, the forwarding information base cached in memory so that it can move quickly. And if your router doesn't have the memory to handle it, poof, you just disintegrated it right there with that one command. Because of that, Cisco has also made this an interface by interface basis command. If you just want to turn on Ceph for routes on a specific interface or need to use features supported by Ceph on a specific interface, just go under that interface and type in IP route cache followed by Ceph. And you can see that those are here are the major routing, policy-based switching and process switching, and Ceph is right up here. So I can turn it on under that individual interface. I rarely Now, I'll tell you what, I've never used that command in production. It's there, it's supported, but usually on a router, it's all or nothing. You either enable Ceph everywhere or you don't. Now, once you do that, you can go out and type in show IP Ceph detail. and find out what's going on with Ceph, and you'll be able to view the forwarding information base. Looks a lot bigger than you thought, eh? Forward information base sitting in cache, and you can see, this is just for a routing table of 3 routes, if I remember right. Show IP route. Yep, 3 connected interface. This is what the forwarding information base looks like. So Ceph has done its job. It's got the cached information base in memory. Now we can move into mpls. mpls is configured on an interface by interface basis. And we're going to have to go, whoop, I just telnetted back over there. We're going to have to go underneath each individual interface that we want to enable Ceph for, or sorry, mpls for, and turn it on. It's very easy to do this. Let me go into the Ethernet interface, and let me just again do a show IP interface brief. Ethernet 0/0 is what connects to Pine over on the other side, and then I've got 2 loopbacks just to generate some networks and some routes. So I'm going under interface Ethernet 0, 1 command. I type in mpls followed by IP. Enter. That's it. At this point, what's happening is the router has now begun enabling mpls for this interface. And it's assigned a label to every single network that it's got in its cache. Now, the second piece is going to be turning on the routing protocol for mpls, and that is LDP, the Label Distribution Protocol. I've got to get out of the habit of calling it a routing protocol because it's kind of like a label protocol in the sense that it is responsible for sending the labels that this router picks to other routers so that they know what labels to send over. So watch this. I'm going to type in mpls LDP, turn on Label Distribution Protocol. And you know what? That's not what I wanted to do at all. LDP Discovery, sorry, I was going the wrong direction. LDP Discovery allows it to discover other LDP routers out there. That's not what I want. The command I want to go under is mpls label. Now you can choose what protocol you want to distribute those labels. So right here I'll hit a question mark and let me explain this. You see LDP, which is what we know, the Label Distribution Protocol, and that is the one right in the middle there. And then below it you see TDP, which we have not seen until this point. TDP stands for the Tag Distribution Protocol. It is Cisco's proprietary label distribution protocol that's out there. The danger of this is that it is not an industry standard protocol, and it was only created to implement MPLS before there was a standard. Now, I mentioned early on in the concepts video that this feature was implemented on Cisco routers before there was even a standard. Cisco created TDP, the industry standardized on LDP, so now Cisco has this, I wouldn't call it a problem, but a problem where there's 2 protocols supported on their routers. The good news is that they do allow you to run both, but in modern implementation, that's the one that you use. The Label Distribution Protocol if you want to stay industry standard. Now, if you have a router, it's not a hardware thing, it's a software thing. If you have a router, SmartNet is expired, you can't get an iOS upgrade, and the only thing you can support is TDP, well, that's okay. All you have to do is get a router that can speak both of them, and it can translate for you. They do exactly the same thing. TDP and LDP send the labels. They send the same kind of labels. There's just some slight tweaks in TDP that make it incompatible with LDP. So it's not like one's better than the other. It's not like the proprietary gives you extra features. It was just there first. So let me exit back out of here, and now I'm going to hop over to Pine. And on Pine, let me do a terminal monitor because I'm telnetted in. I want to see the console messages as this happens. I'll get under Pine's Ethernet 0 interface and I'll type in the same commands. MPLS IP, turn on MPLS, and I'll type in MPLS label protocol LDP. So we turn on the label distribution protocol. Now what we've done at that point is allowed the 2 to communicate. And look at that. Isn't that awesome? We have LDP neighbors coming up. It's just like as if EIGRP went active and discovered some neighbors. The labels are now being distributed between Pine and Redwood so they know each other's labels. And guess what? they're doing MPLS. Now, I know it's not spectacular. It's not like, wow, everything is just falling into place, but they are doing MPLS between each other for their routing table. So they've assigned the labels and they've told each other what the labels are. Now, I'm going to go a little beyond what the Cisco ISCW certification exam requires, because that's really all you want to know about MPLS for the certification exam. But there is a full course dedicated to MPLS, and that's why this is just a tip off the iceberg. But you can verify that MPLS is happening. I'll type in show MPLS. Let's check out the let's check out LDP information because we want to see what's being distributed. I'll type in show MPLS LDP neighbor, and this is from Redwood, and it has seen a neighbor at 192.168.1.1, and you can see that its local identity, it kind of picks its own identity when it's communicating, is 10.2.2.1, which is the highest loopback interface. It's kind of like OSPF's router ID that it picks. My brain is just checking out on that. So, as you come down, you can see the state, messages sent and receive, the uptime of these neighbors, what interfaces it's going out. It's just, just like a neighbor table for routing protocol. I can then type in show LDP bindings. Here's going to be the interesting part. And I'll just view all bindings. And you can see that it's gone through and it's created a binding for itself down here. It's 192.168.1.0. That's going to be the local interface. And as it's going through, you can see the different tags that it's assigning to each and every one of these routes that it's sending out. Now, it's showing that this is from the router 192.168.1.1, which is Pine. Pine's tag for it is 17. Pine's tag for 10.2.2.0 is 16. You can see those right here on the individual entries. So we can verify and see what tags are being distributed between those different routers. So I'm sorry, I don't mean to drag this on longer than it needs to go. That's it. That's all it takes to turn on MPLS between the individual neighbors. Now, the last thing we may want to do is make our MTUs a little bit larger. The reason why is right now, by default, the interface uses the default maximum transmission unit of 1500 bytes. But when labels start to get stuck onto there, it's going to push it above 1500 bytes, which means it's not that the communication dies, it's that the router starts fragmenting packets and chopping them up and becoming less efficient. So what we want to do is get underneath the interface and increase the maximum transmission unit to allow it to go above 1500 bytes. Since I'm over here, I'll start on the Pine router. We'll get into interface Ethernet 0/0, and the command to do this is MPLS MTU, and then you type in what the maximum transmission unit is. Now, it's recommended that for MPLS enabled interfaces, you use 1512 bytes. The reason why that is an individual MPLS label is 32 bits. If you divide that out, that's 4 bytes in size. Now, the way MPLS standards work is that you can have a maximum of 3 labels applied to any one interface. So 1512 bytes allocates enough room that if somebody was putting 3 labels on an individual packet, did I say interface before? I meant packet. If people are putting 3 labels on a packet, the maximum it will be is 1512 bytes. Enter. Pine is done. I now go over here to Redwood and do the same thing. MPLS, MTU, 1512 bytes, and we're good to go. Now, if you have a switch in the middle of these routers, which is the norm, or you have some kind of intermediary device, do know that the maximum transmission unit defined for Ethernet is 1500 bytes. I just went above that, and in this case it's okay because I just got a straight crossover cable between these routers. But if you have a switch, you'll want to go to that switch and allow it to accept Jumbo frames. That's what it's called. It's like jumbo shrimp. Jumbo frames are frames that are above 1500 bytes. By default, a switch will see those and say, oh, there's something wrong with those. I'm going to drop them. So it's different for every switch platform. It's different based on Cat OS versus native iOS, depending on the software you have on the switch. But just go to the reference guide for whatever switch you have and find out how to allow it to accept jumbo frames, and then you're good to go with your MPLS. That's all there really is to enable frame mode MPLS. And I want to make sure you guys catch this. That's not all there is to MPLS. Remember, this is kind of a sliver out of an entire certification track that Cisco's developed, where MPLS is one of the core pieces of it. When you start getting, when we get into the concepts in some of the upcoming videos of MPLS VPNs, you're going to start going, oh, that's why there's a whole course for it, because it gets much bigger. So, major things to do. Activating IPsec. Go into global config mode and type in IPsec, one command there. Second, enable the interfaces for MPLS, one command there. MPLS IP under the interfaces, followed by MPLS label protocol LDP. You want to use LDP rather than TCP. Finally, you want to increase the MTU not so much for functionality but efficiency so that the router doesn't begin fragmenting your frames because they're too big. Also remember the switch side of that we just talked about. And then I threw in some of the verification commands that you can use, like show MPLS followed by LDP to start looking at the replication information. You can look at the interfaces to see which ones are turned on. Just type in show MPLS question mark and you'll see a whole slew of commands you can use to dig into just about every piece of that. I hope this has been informative for you, and I'd like to thank you for viewing.